So the problem goes like this. A manufacturer of coats, watches, a manufacturer of coats watches claims that 2% of his product is defective. A retailer buys a batch of 720 watches from the manufacturer and finds that 26 watches are defective. Test at 1% level of significance that the manufacturer's claim is justified. So here we have to test the population proportion, because you are given that a quartz watch manufacturer is there, and out of this quartz watches, his some of his products is defective. So the total population is divided on the basis of defective items and non-defective items. So there is a characterization of population. Hence, here we are using testing of population proportion. So he claims that all his population, that is all the quartz watches produced in his factory, contains 2% defective. That means we have to test whether his claim is justified or not. So here our null hypothesis is H naught P is equal to, what is his claim? 2% of his product is defective. So H naught P equal to 0.02, 2%. And against the alternative that H1P not equal to 0.02. Since in the problem you are not given less than, greater than, uh, all these keywords. Okay. Now you are given that a retailer buys a batch of 720 watches, that is n is equal to 720, and he finds that 26 watches are defective, that is x, the number of units having specific characteristics in the sample is 26. So what will be our p dash? 26 by 720, that is our p dash. So which is our p dash, and since p equal to 0.02 in the null and alternative hypothesis, p naught is 0.02. So what will be q naught? Which will be 1 minus p naught, that is 0.98. This is our p naught. Now what is our test statistic? Test statistic is z is equal to p dash minus p naught divided by root of p naught q naught by n. This follows standard normal distribution. Now let us substitute the values. So p dash is 26 by 720 minus p naught is 0.02 divided by root of 0.02 into 0.98 by n is 720. Now let's see what is the value. (26 by 720 minus 0.02 divided by root of 0.02 into 0.98 divided by 720, which is equal to 3.0879. So this is the value of our test statistic. Now since our alternative hypothesis is H1P not equal to 0.02, our critical region will be, the critical region is what? Modulus z greater than or equal to z alpha by 2. Okay. Now we are given alpha as 1%. So given alpha equal to 1%. Then from tables, what will be Z alpha by 2? Z alpha by 2 from the tables will be for 1% level of significance. For 1% level of significance, Z alpha by 2 is 2.58. So Z alpha by 2 is 2.58. Now let us compare the values. So modulus Z is equal to 3.0879, which is obviously greater than 2.58, which is Z alpha by 2. Then we will, so this is true. That means value of Z falls in the critical region. If this is true, that means value of the test statistic falls in the critical region, that is rejection region. Hence we reject H0. That means the claim of the manufacturer is not correct, because we are rejecting that 2% of the defectives are there. His claim is that, and we are rejecting this claim. Okay, so we can conclude that the claim of the manufacturer is not justified.